Now we have a distinguished speaker with us, Mr. Kumar Abhishek Singh. Just let me brief his profile. First of all, I would proud to introduce that he is alumni of VIT Chennai. After completing his graduation in BTech CSE in VIT Chennai, he has a wide experience in different companies. Uh, he joined as a software developer in Sapient, which is a digital transformation company in Bangalore. And further, he worked as a team lead for the company called Asena, which is a major retailer in USA. And then he became an analytics consultant at Thoroughgood Associates, Bangalore. Currently, he's working as a chief technology officer at Comdex, which is a blockchain-based company situated in Bangalore. His area of interest are blockchain technology and finance management. He's going to deliver the lecture on blockchain technology in the industry point. Now, I request Mr. Kumar Abhishek Singh to take over this session.
Thank you, Rajkumar sir, for the
எல்லாம்
introduction.
ரிப்ளை பண்ணதாக பேசுங்கிறாரு பாரு.
If you could put them on mute, thank you. Okay, so hi everyone. It's good to talk to you guys after, I don't know, it's a huge opportunity for me to be able to speak to you guys, and I hope all of you are safe and well at home. So today I'll be trying to give you a brief about what blockchain is. I'm not sure if you guys have been following the industry, but if you look over LinkedIn, it's been the one of the most sought after technologies, and even in India with the recent development, you will see the government trying to focus on blockchain as a key technology to develop the new India. uh, Blockchain as such, it's a very foundational technology in nature, and it's very nascent also. Bitcoin being the first implementation was around 2009, and then it's hardly a 11-year-old, 10-year-old industry, and you will see a major boom coming around 2016. So hardly anyone with more than 4 or 5 years of experience, and which is a very good thing for people who want to target working in blockchain, want to learn about the blockchain, because it doesn't really have a legacy of its own, and then we will be the ones building the legacy around it. So just to cover what all I'll be covering, so I will be giving you an overview of blockchain, and we'll discuss a little bit about trade finance, and what are the challenges that are being faced by the commodity trade industry in the world. Commodity trading, as you know, is like one of the oldest industries of the world. Commodities have been traded for centuries now, and if you look at it, it's a very rudimentary processes even till this date. So we will be covering what trade and trade finance are. Then I'll quickly try to cover what we are doing at Comdex, and what is the blockchain implementation. We'll discuss a little bit more about it. And I also got a chance to consult NTPC regarding a peer-to-peer power trading use case that we suggested the architecture for. So I will briefly discuss the problem as well as the solution for it, and we'll quickly try to cover the industry trends and what has been the progress. What has Niti Aayog been up to. So and it's very amazing what even the government organizations have been able to achieve over the last 2 years. And finally, we'll be discussing the limitations of blockchain, and I'll certainly take up any questions if you guys have. So just to start, uh, so basically this is the blockchain definition, the textbook definition. But if you were to ask me what blockchain is, so of course it's a chain of blocks, but the very first block of the blockchain is called the genesis block, and it holds all the data that is required to be there at the beginning of the chain, and then at each subsequent block uh, history is added, which shows what was there in the previous block, not exactly the data, but like a hash of it, or what is called as the Merkle hash also. And it also contains the data which will the transactions which will come across and sit in this block, which and the hash of it, so that this is how the chain is formed. One reference to what was the previous state, what is the current state, and this uh, maintains the sanity of the system. And blockchain is a like a subset of a distributed ledger technology. So it's, if you go through the slide, it is a digital ledger of transactions that is duplicated and distributed. Now, what does duplicated and distributed means? I mean, duplication is not really something which people look out for, right? But if you look at any of the blockchain architectures, you will never find a single point of failure. And that, I believe, is one of the most important features, that since the duplication is at a network level, each node has all the data. It is one of the best, most secure way to store something which you never want to lose. So each block in the chain contains a number of transactions. That is fine. Every time a new transaction occurs, a record of that transaction is added to every participant's ledger. So I'll be going through how this works, how what are the consensus mechanisms that are being used. So my company is based on top of another company which is called Persistence, which was also co-founded by one of my batchmates from VIT itself. And we have built the application on trade and trade finance on top of them. So it is, I mean, you need to understand the different kind of mechanisms that are in place. I mean, every blockchain is different. Some people use different set of consensus mechanisms, which widely vary across the types of blockchains, which I'll be covering. So, and all that definition in terms of feature, it just means that everything is digitally available. uh, Trustlessness is another very big thing. So if you look at the world around you, every time you find an intermediary, let's say when you're buying a house, you need a broker. When you do anything in between, the whole supply chain around the world is built on intermediaries. And uh, all these intermediaries add up to the cost of the last part of the I mean, the product gets costlier because if the supply chain becomes longer. So, and in a sense, each party is just providing trust at the end of the day. Each intermediary that you do, even if you take the example of Uber, if you take the example of Swiggy, at the end of the day, these are trust providers telling you that, sorry, you might not know who the best cab provider is. And of course there are things about efficiency as well, but they are like the central broker for cabs. Uber, probably Swiggy can be regarded as central broker for food. And uh, trustlessness means that if imagine something like Uber was based on blockchain, on a blockchain network. Even if Uber goes down, the network still remains up. But that doesn't really happen when it is a centralized system. And that is why it's not liable to anyone, because if, as long as the network is up, it doesn't matter if a couple of nodes go down, etc. And of course it facilitates peer-to-peer exchange, and this is how it removes the need for the intermediary. Because if you were to able to pay the cab driver directly, you would certainly get a 25% discount, because that's what Uber charges them. But and these three form the fundamentals of the blockchain. Now, of course, key elements, it's a distributed ledger. What exactly is a distributed ledger? It just maintains all the transactions that have been done, and any change that has to be done on top of it. So let's say, you did 5 transactions, the sixth one, you made a mistake. Now, you can't revert that mistake. You have to have another transaction which will say that mistake has to be corrected, and then everything still gets to be visible. So that is basically a distributed ledger. records are immutable. Like I said, if something has been done, it has been done forever, cannot be changed. And smart contracts. Now, smart contracts, although I've taken this data out of different places, but smart contracts is basically a Ethereum word. Ethereum was the first one who came up with smart contracts, and what they mean is just basically a rule set. If and who is the actor which is going to fulfill the rule set. So if those conditions are fulfilled, the contract gets executed automatically. We'll also discuss limitations around this concept and why things were failing. But yeah, this is basically a smart contract is a predetermined set of rules, and if those rules get fulfilled, it will get executed automatically without anyone's intervention. So let's just briefly discuss the Byzantine generals problem. If you guys see the screen, on the left side of the image, so this is a very theoretical problem, probably mentioned in one of the papers in 1982, if I'm not wrong. There is a city in the center, and each person that you see standing is a Byzantine general, and none of these generals are individually capable to win over the city. I mean, the aim is to attack the city and win it over, but all of them have to coordinate the attack to win. Now, how do they communicate? It's and you see there is a crown on top. So let's say this crown decides we have to, let's say, attack at 3 o'clock, and he can just communicate to the two people around him. He does not have the means to uh, talk to everyone, or if the crown sends a messenger around, that messenger around might be killed, or one of these people might change the message themselves. So if you see on the right side, there are traitors as well, who might change the message in the what the crown has sent. So in such a situation where the network is not secure, and a message has to be passed, and at one point in time all of them have to agree to attack. So these are the conditions of the Byzantine generals problem, and a very theoretical problem, because if they don't attack at the same time, they actually lose. So the aim is that at an x point in time, of course, there is no concept of time in blockchain, it's just the block height which is used, but uh, at which block height do all of them really decide to attack, and how do you do it over an unsecured network? So now Bitcoin is the first working implementation of this problem, in a sense, because this problem never had a working solution before. And then that is when, although what can, just to discuss what can they possibly come up with, they can just say, predetermine the rules of the the time. Maybe they can say every time I give you a time, it will be after 12, it will never be before 12. And that is like the rule set that each of these nodes will be running. Now all these nodes are at the end of their day running a software, right? So that software is that set of rules. And if anybody tries to say no, this they wants to change the message, they instantly uh, the other members always reject it, because their code says the answer should have been 3 if the other conditions were met. Likewise, now since one person cannot really communicate with all of them, so they use something called the gossip algorithm, which is you tell it to all your peers, and those will tell them to their peers, and each person on the node is expected to have at least one peer, so that gossip algorithm takes care that each of them are informed on the time. Now in terms of Bitcoin, of course, it was made with building a currency in mind. So now these people are in effect exchanging a number called time, and Bitcoin does the same thing but calls it money. So the whole logic is same between most of the consensus algorithms and different kinds of blockchains, but this is what they were trying to solve. How do you communicate over a unsecure network, and how do you communicate in a decentralized fashion if some of the nodes might go Byzantine? So, and that is why, of course, in 2017, Bitcoin became a household name, which is probably not very good for the industry such, but just to map out the differences, because blockchain and Bitcoin have been used interchangeably for quite some time now. Although we are getting out of it now, people are embracing blockchain more than ever. But just to lay it out for you guys, so Bitcoin is primarily solving the Byzantine generals problem, but as currency and not as time, as they were figuring out. But it is a cryptocurrency, while blockchain in itself is the underlying technology which powers Bitcoin. uh, if you look at like I said, Bitcoin is primarily currency, while blockchain, like in my case, I transfer commodities and money as well based on blockchain. But I'll just quickly go over the types of blockchain, because if you see multiple implementations, you will hear people talking about likes of Bitcoin. Then you will see people talking about Hyperledger or Coda. So what exactly are all these things? They're divided into four things. One is a public network. Another one is a private network. Another is consortium, and the fourth one is the permissioned blockchain network. Permissioned is more like a private with a kind of a hybrid solution between public and private. But then, so what really is a public network? So if tomorrow you wanted to become, I mean, any one of you wanted to become a Bitcoin miner, you just start running that program, and nobody stops you from joining the network. Anybody who wants to run a node on the blockchain network can do so, and that is what is a public blockchain network. A private blockchain network is the exact opposite of the public network. It is usually very limited to one organization. Let's say internally VIT decides to run a blockchain based network where people can probably uh, maybe have their marks put there so that they become immutable and can't change, or whatever, having degree records, etc. So in that case, PIT doesn't really would not permit other companies or networks to access the chain. And even if they provide access, they will never allow them to put any transaction on it, because since somebody is issuing a degree, only VIT is like the oracle who can say that the degree is here. So they won't allow other people to have a transaction on it. It might be visible to other people, but uh, they will never allow a transaction on it. So that is a private chain network, that all the nodes of the network would be owned by VIT in that case. And it really depends. Some purists of blockchain would never call a private blockchain a blockchain. They would just call it a DLT and not call it a blockchain. Reason being, if the system is completely private, it becomes more like a distributed database in which all nodes. If somebody really wanted to revert a transaction, they could do it, because there is no financial loss in reverting those transactions, because no other party is involved. And this is the significant difference between people implementing on Hyperledger versus people implementing on Ethereum. Because a use case where people were doing this was in the pharmaceutical industry, where they were doing drug trials. And one of the companies in the US, they failed a drug trial, but and now, since everything was on blockchain, they could not like remove those records to get the FDA approval. But I believe it was Ranbaxy. But yeah, uh, what they did was, since all the nodes were owned by them, they reverted every single transaction, created a new blockchain altogether. So it makes, as a governance tool, private blockchain would never work. And just to solve this, they made a permission blockchain. So in the case of VIT, probably what they would do to avoid such things is they might invite other universities to put their degrees or whatever on the chain, so that now each node operator is a university in itself. So now if you change anything, the other universities will also know, and it is difficult to make things hidden. And unless all the nodes of a okay, sorry, I think I missed one part. So for reaching a consensus, you always need 67% of the people to stay aligned. And why 67%? It's a very simple thing. If two people discuss, they can never come to a consensus, because it will always be 50-50. But if there are three people, then only then can a consensus be reached, that two take one side and one on a different side, and that is 67%. uh, and that is the minimum requirement to run a blockchain, that at any proposal, any blockchain, any block to be added in the chain, at least 67% of the validators or miners or whatever have to be aligned. If they don't do it, the chain in theory splits into two different chains. And if you look at Bitcoin over the years, it is split into Bitcoin Cash, Bitcoin Gold, or whatever. So what really happens is that miners decide that they want to do a specific implementation which the other miners don't agree with, and they part their ways, and the chain splits. But ideally, at least 67% people have to agree. And in case of a permission blockchain, in the universities example that I was giving, if there are like three universities around, at least two of them have to collude to change anything otherwise. And as the network grows bigger and bigger, it becomes increasingly difficult to make any changes. So that is the true power of blockchain, where governance becomes so engraved that any mistake that you do, it cannot be hidden, and which is a very great thing in the real world. A consortium blockchain network is something which recently came up with, not very recently, but yes, Facebook's Libra. They decide on top 10 companies who can improve the code, who can improve the chain, who can add value to the network, and then those are the only people allowed to run nodes, change the code itself. And of course, they don't blindly change the code. There is a proposal for that as well, but that is more of a from an organization perspective, but it is kind of a permissioned blockchain network. And then when do you decide to use a blockchain? And this diagram has come out after a lot of research that Niti Aayog has done. If at every single place, it's not really wise to use blockchain. Reason being, no, the very first limitation is that blockchain itself is very slow. Now, what do I mean by slow? Now, each time, if you refer to this diagram, each time, they have to decide on a time. They need to wait for the message to pass between all the generals. Now, what that means is, uh, each time the crown says, let's attack at 3, till the point it reaches everyone, it is already delayed by, let's say, 6 seconds, 10 seconds, 12 seconds at least. My current blockchain runs with a average block time of about 6.7 seconds, but uh, and that is a delay, right? Because although each block can have multiple set of transactions, and let's say 100 transactions came into queue, so you have to have some kind of queuing mechanism like Kafka itself, etc., to put them into queue, put the transactions into a memory pool where they'll get picked up. So all this causes a lot of delay in a simple database system, or a simple application. It would just be direct, and there would be no consensus or waiting of any kind in between. So this is the biggest limitation on why you should not just randomly put blockchain everywhere, because it doesn't really have a high transaction per second. If you guys remember, probably in 2018, on the Ethereum blockchain, CryptoKitties was launched. The day it was launched, the Ethereum network went down, because it cannot still support more than 1,000 transactions per second. In contrast to a Visa or Mastercard doing 60,000 per second, and stockbrokers like Fidelity Investments, they do close to 1.5 lakhs transactions per second. They're based on COBOL. So uh, blockchain in that manner is very, very nascent. And this this diagram probably, if you guys are really interested, should go through the Niti Aayog paper, because what if I can go over this very slowly. So if is there a compelling case to reduce intermediaries? Now, like I said, if there are let's say hundreds of brokers in between your product and the company who's manufacturing it, certainly it makes sense to have a blockchain, because intermediaries equates to trust, and if blockchain can build that trust, then probably you don't need all the intermediaries. But if there are no intermediaries at all, there is absolutely no case for blockchain. uh, Now, multiple stakeholders, that is two or more, if they have like two or three people who are determining what has to be decided upon, again, you do not really need a blockchain. Now, do you work with digital assets or physical assets? Now, this is very, very challenging in all of the implementations, because the traditional manufacturing houses, the commodity traders, or whatever you want to deal with, they were not digitized, in a way where you can directly uh, tokenize them or put them on the chain directly. Reason being, although they have systems like SAP building ERPs for them, but on a deeper level, they've not really, at a SKU level, they've not really gone down and uh, separated everything out. So they do it more from a people perspective, they do it more from a P&L perspective, but not really from a product or SKU perspective, which really becomes a huge issue when you go out to develop something for them. So for example, let's say in shipping companies, they when you put something on a cargo ship, they give you a paper called bill of lading. Now, that bill of lading has historically, from centuries, been a paper document, and you give this paper document to the other person on the port who is going to receive that shipment. And if you don't have that document, the captain of the ship would not unload that, on the destination port. So that acts as uh, a title document, if you would call it, for ownership of whatever is the shipment. Now, if something like that is only on paper, there is absolutely no way that you can tokenize something on top of it. And probably that is one of the limitations of my of my domain as well, where such important work is still done on paper, that you can't really prove or disprove after a while that which one is the original document, unless you are the one who is, of course, originating it. So, and then none of the shipping companies are interested in technology, because it doesn't really make sense for them. So if you have something of that sort, then blockchain again does not make a lot of sense. Now, so this is what, so 3A, 3 certainly did not work for us, but 3B, if you look at, can you couple digital assets with physical assets with permanent and authentative proof of record of proof? This is what we have gone ahead and implemented, because what we do is we take that document, take the hash of the document, and then say put it on the chain saying this was used to make the trade, and these are the details on top of it, and that can be mapped to a actual commodity in the world. So we take a different route to just build that token, instead of directly uh, trying to onboard shippers on the platform so that they can be the originators. But that's really very impractical to imagine every single entity of the supply chain to join one platform and do it. Although Maersk went ahead and did this, but because they can, they have a oldest supply chain in the world, but very difficult for a new entrant to do that. So that is why you need to think about possibilities, you can come up with 3B so that you can still go ahead and implement blockchain. Now, do multiple parties require shared right access? Probably doesn't. It's a good thing to understand, because like in the example of the university that I was quoting, only VIT is supposed to have right access, right? Nobody else is supposed to have. So if multiple parties don't really need, so there is no use for blockchain. Why would multiple parties need? Only if you have it in a multi-university setup, that each university is on the same network. That means multiple of them need right access. Otherwise, again, it is, if it's only one university doing it, it doesn't really need a blockchain. uh, do you require high performance rapid transactions? Yes. Now, if you look at this, blockchain can't do this effectively yet, and this is what I was discussing earlier. But what they've come up now with is something called uh, slipping my mind, a plasma solution. So what that means is, instead of just having one set of transactions in the memory pool, it creates a side chain in which all the microtransactions are done. And at some point in the future, all those microtransactions are dumped on the chain as one single transaction. So what this effectively does is have, it's kind of a grouping, if you would call it. You group x number of transactions together, so the total set becomes smaller, and then you can still achieve higher TPS. But then, it's still in development, very difficult to understand how it will, if something goes wrong in one of the transactions, then who's to be held liable, and what will happen to the other set of transactions, because the block won't get committed. So do you want to rely on a trusted party for compliance reasons? So obviously, if you map anything to the real world right now, India, I would call, is a really advanced country in many manners, because with things like Aadhaar and UPI, many, it's not the standard across the world. So my company is primarily based out of Singapore, and they have huge compliances, although the government works very fast. But then all this compliance, and anytime you deal with money, you have to cater to anti-money laundering and KYC as well. So, and all those things you cannot, of course, do in house, so you have to depend on other people. But do you need the ability to control that functionality? Obviously, yes. At the end of the day, if you can create a huge transparent uh, list of things or trade activity that somebody has done, it becomes very easier to get financing for those people, which I will discuss. So this also discusses when it should be a public chain and when it should be a private chain. And what we have gone ahead and made is a permission chain, which is a hybrid between a private and public. Reason being, should transactions be public? We did make it public, but then hid away some of the details, so that uh, the confidential information of a trader, which is the trade book itself, is not exposed to the general public. But of course, if somebody like really wanted to sit on the explorer and check all the transactions, they might have an idea who is trading what, but it becomes very difficult. Another research that has been going on in the world is something called zero knowledge proof. This would eliminate the need for a private blockchain ever, because at the end of the day, if you have, so what is a zero knowledge proof? It basically means you're able to prove something without really knowing what it is. So you might not know it's 1 plus 1 is 2, but if somebody tells you 2, you can prove that it's 2, and if somebody tells you 3, you can prove that it's 3. On Ethereum. But for other kinds of transactions, work is still in progress, because This is the most challenging thing to have because you need uh, a separate function for it altogether. So of course, why blockchain? If you look at things around you, you will all once you really understand the governance part of blockchain, it becomes, you would think each system in this world probably needs a blockchain implementation. Think of think of government subsidies or government projects. If somebody really wanted to know how the money was spent and at each step, of course you can file an RTI, but then there is no easy way for a normal person to go through and check all the history of all the transactions. If you look at anything which requires governance, the Uber example that I was giving you, so that in effect the deal is between you and the driver, right? There is no, it doesn't make a lot of sense for you to pay a lot of premium to Uber for that. If you make a decent, only question that remains is who is going to build the network if nobody is going to profit out of it. But and that is something is the real inhibitor of the progress, because if any case which is like a hourglass figure on the left hand side, if this system fails, it will be chaotic. Although we have mechanisms in place and there is no real incentive for the guy in the middle to close operations, but in theory if they ever did it, it'll become chaotic. And then what will really happen is we give the power to control prices to this central person or company or whoever this is. When we have a mesh kind of an architecture, where each node is independent, each of these independent node gets to choose prices as well. So what I mean by that is, if you imagine 10, 15 years down the line, when there is probably Uber is the biggest cab company, it is now also, but probably Ola is not really significant by then. Uh, Uber technically controls all prices in the market. uh, you cannot really argue or change anything about it, unless probably a lot of cab drivers yourself. You will have to be dependent on prices. But if you have a mesh structure, each of the nodes on the mesh act as a separate company altogether. Probably if you can run a node and you pay this network only for the traffic that is going through him. Now this creates a competition between all these participating nodes, and this will ensure that the prices are not just controlled by one person, because this is a true marketplace. This is monopolistic view, which down the in the long run might not be beneficial for the public. Of course very beneficial for the central person, but not really beneficial for other people. So, and this is the primary reason I think we would need more implementations of blockchain. uh, I'll just quickly now jump to trade and trade finance and how commodity trading works for you to understand what we've went and developed. uh, so think of two people in separate jurisdictions. Probably take an example of a person in Singapore trying to sell 100 tons of coal for $1 million to another trader in, let's say, Malaysia. Now, of course, now this person who has the 100 tons of coal, he knows the person, but how will the transaction take place? So, the Malaysian trader will say, okay, I'm interested. Both of the parties will sign a contract. Now, the Singapore trader would, in effect, put that 100 tons of coal on the ship and get that bill of lading that I was talking about. Now, he has to transfer this bill of lading to the trader across the border in Malaysia. Now, how would that work? Because, and of course, the Malaysian trader has to pay him back $1 million before he, uh, gets the goods for himself. Now, usually what happens is, you will find people having a letter of credit. the Malaysian trader will say, I don't have the finance right now, but I'll give you a letter of credit that my bank is issuing, so that you know that you can take that 1 million later. And the Singapore trader sends the bill of lading so that he can take the delivery. But now the bank in Singapore will not trust the bank in Malaysia, just because they are in separate jurisdictions, and then they don't even have a working relationship. Now both these banks appoint a correspondence bank, which brokers the deal between the two banks, where one takes the LC and the other takes the bill of lading. Now all this process, if you see, one trader, one bank, another trader, another bank, and a bank to solve everything else, this is only because the problem with trust. If the people were in the same jurisdiction and these people were trading, absolutely no issues with trust. The bank doesn't need to worry because they are both in the same jurisdiction. And they avoid a lot of problem having everything in the same jurisdiction. So why is it important for blockchain in this space? Because blockchain removes intermediaries, provides trustlessness. By trustlessness, I mean you don't really have to trust a bank or a central authority or whatever. The system itself that you've built is so robust and so provides that kind of trust that something other than the required behavior cannot really execute on the platform, which Ethereum calls smart contracts, and I call an escrow. But this is what really happens. And if you look at reports from Singapore from April this year, old commodity traders who've been doing good business for decades, they went bankrupt. Now how is it possible that you've been doing billions of business and in 2 months of slowdown somebody collapses? So this is a classic case of people doing refinancing on a trade. So let's say the Singapore trader in our example wants to sell the same 100 tons of coal to a trader in Mumbai, and he just takes a copy of that bill of lading and uh, sells it to two people. Now when the time comes for payment, he takes, because you need to realize, when the goods are on the ship, they get traded close to 15 to 16 times before reaching the actual user of that commodity. So all these traders are not really suppliers or users of that commodity. Their primary motive is the price difference between, and that is why they're just traders. Financiers, on the other end, they would just jump in and come up. If you have a good trading history, you can get a lower rate, and that's what those people are interested in. So there is absolutely no worry about the coal here at all. It doesn't really matter. Of course, there'll be some issues at the end point, but if you look at Nirav Modi's scam, generating fake letters of credit, so that is from the buyer's side, that they can fake the letters of credit. On the seller's side, of course, he can fake the bill of lading. So how do you make a system where everything is put into check? So this is when people came up with Comdex. Uh, we are like a 3-year-old company now, uh, and what we basically specializes in is trade finance. But how do you do finance on something where you don't really have a verifiable audit trail? So keeping that in mind, we did not go and solve the problem at the level of onboarding shippers so that the bill of lading itself is always in the digital format, it's always original. Instead, we built everything on top, assuming that the user which is putting it down is going to put down the right information. Now, of course, in theory, it is all wrong, but what we hope is other people who are already working in the space, they will come up with a solution. And at the end of the day, all those commodities will have to be financed. So this is the motive of building Comdex to commoditize, to tokenize all the commodities, where when somebody says I have 100 tons of coal, he puts all the data of the bill of lading in a, okay, I have not discussed what a NFT and FT is. So a non-fungible token and a fungible token. So think of money. Money is a fungible token. Okay, so the 10 rupees in your pocket and the 10 rupees in mine are interchangeable. I mean, there is absolutely no difference. But if you were to really, think of, let's say, a product. Okay, now a same model, same car, people would not like to exchange because all their histories might be different, because they are not something which is not easily interchangeable is usually implemented in a non-fungible token, and something which is interchangeable like money usually is implemented in a fungible token. Fungible just means it can be just split and added however you please, but things like cars, you can't really split and add them as you please. So that's the primary difference. And how do you tokenize it? So you need to have, always in any architecture, have to have a mapping which has some resemblance to the real world. Of course, from a systems perspective, you can give it a randomly generated ID which is always unique, etc., etc., but that ID doesn't really have any value in the real world, right? So we have to come up with a process where, if you pick up a token, you can instantly map it to something which is in the real world. And that ID is not generated by you, because if we start generating IDs and giving it out to people, then we become the central authority for that, which is the exact opposite of what we were aiming to do. So how do you do it? You take all the data of that bill of lading, and we've been extensively working on you trying to use machine learning to read that bill of lading. But since that is not a standardized format, and it's been a difficult journey to do it, even after Amazon launched Textract, which doesn't really help. It's still evolving that product, but you need to have that mapping, the bill of lading number, the captain who signed the bill of lading, what was the weight uh, of that commodity, what was the starting port, what was the ending port. So all those things, if you capture and take a scan, put the hash of that document, uh, of that scanned document on the blockchain as properties of this token, what this makes happen is, every time now, if somebody is traded using that token and they've put this document with all the details in, there is no point where they can turn back and say this has not happened. And that is how, or they can say, there is another BL which I meant to upload, but I uploaded a wrong one, because it cannot really happen. If you've put every detail in, you've taken the hash out, all the trade has been completed, there's no chance of going back. There is no chance of uh, people refuting that they've done something else, because the way it happens on the platform, it cannot really revert itself. So this is what we've been trying to do. uh, what we've also made is a custom escrow creation. Now, if anybody of you has done anything in Ethereum or Solidity, or you will always find that the contract creation, after it's created, the chain is made. Now, if you make any change to want to make any changes to the smart contract, you have to, in essence, start a new blockchain. And this is what we had been stuck on as well. So we persistence, the blockchain we are based on top of, that is based on top of the Cosmos blockchain, or the and that is built on the Tendermint consensus algorithm. But we also had the same problem where, if you want to change the order, a way a order happens, what exactly is an order? An order would just say, one user sending the NFT, which is the commodity, the other user sending the fungible token, which is money. And when it sees both the values are same, uh, it executes the order and the tokens are exchanged between the two parties. Now let's say, a financier comes along and says, I want to buy this and this and this, buy this and this, I mean separate set of tokens. Now instead of and wants to pay one time directly for all the three commodities. Now this escrow cannot really handle it, because it's uh, built only to exchange one thing with another. What we have gone ahead and now developed is a custom escrow, where we've kind of built a framework where you can always, you know choose how you want to build the escrow, and that custom escrow becomes the new smart contract. Without redeploying, without doing anything, on the fly you create that contract and execute it. So this is what we've gone ahead and done, so that each, because people coming in from different jurisdictions, having no standardized operating procedure, it is very difficult to accommodate all users, who are in the business. So we had to like build this, but this is one of the selling points, where you can on the fly create whatever contracts you wanted. uh, what we have done with on-chain settlement is, of course, if you look at crypto regulations around the world, they keep changing. Even in India, 1.5 years back, RBI said no, and then Supreme Court says RBI doesn't have the authority, and all those things will keep happening around crypto. So we had to move out of cryptocurrency, and Comdex never now owns a cryptocurrency at all. What we do instead is give you kind of a wallet, uh, which says it is provable on chain. What we have done is, we've tied up with Western Union. Western Union, you would know, is just a payment processor, uh, and it has NBFC licenses in many countries, and it maintains float on both side of the currencies, both side of the jurisdictions, and just plays on the forex rates. So, and gives you instant settlement as well. Now, instead of what we really do is, we tied up with Western Union. Now anybody who deposits money in our account in Western Union generates a signed message from their end, and we put this message on blockchain, which generates that same amount of US dollars in the trader's account. Now it will look very very similar to Paytm, but uh, in a sense, if Paytm wanted to change your balance, they would actually be able to do so, because at the end of the day, it's a database. Of course, they won't do so, because they would have, operation procedures around that, obviously. And of course, they have their regulatory compliance as well. But in theory, it was still possible to do. But if you do it in this manner, there is no refuting the point that the money actually came in. If you look at Bitcoin USDT, you would have seen Tether being promoted a lot, but the amount of Tether that is in circulation right now, there is absolutely no proof that the actual amount of money exists to cover if everybody really wanted to sell at this point. And that's a very very bad position to be at, because although nobody's like selling Tether blindly, but it just reflects, if Bitcoin becomes $20,000 tomorrow, they just randomly will double the amount in circulation as well. So not really the best thing to do. But in our case, what we do is, only if somebody has put the money, we put it on blockchain, and then a fungible token is created, where it can be exchanged for whatever commodity the trader wants it to do. So this is the essence on what we've currently achieved. What we are about to do is trade finance. Trade finance, it is like, over a period of time, when there are a lot of people doing the trades, you have a clear visibility from the blockchain, as to which traders have paid on time, which traders have been rated well, and everything. Of course, such data currently exists as well in the real world, where organizations hire auditing firms to come and audit all their financial transactions that they've been doing. But if you look at 2018, 2019, I think there was a case against KPMG as well in India, where it did not audit the finances of a company properly, and which led to a scam. I think it was Carvi, if I'm not wrong. But uh, eh, Carvi also is a very big example on where you need trust, because each time you open an account with a broker to trade, the broker is technically supposed to have a separate account each time a new user is onboarded. They cannot use a common account where they pool their funds together, and which Carvi did and utilized those funds for other things as well. So, though although all those audit reports and financial reports, etc., are present in the world, there is no real proof that it has actually happened. When you put everything on blockchain, this gives you undeniable proof that has happened, and which in turn gives uh, a financier a lot more transparency, and the risk is greatly reduced. By greatly, I mean, let's just think of a normal finance deal for that 100 tons of coal, and whatever 1 million people would say, a Singapore is a very low risk country, at least in people's mind. And if somebody has a decent reputation in the market, they might just get it for LIBOR plus 5, uh, which is effectively 7% on a 180-day term. It's just very, very less, which effectively is like 3.5%, which no trader would mind paying. uh, but if you keep on reducing the risk, I think the rates that the financiers are willing to offer are insane. And why do they do it? Because each time a scam happens, or each time a bankruptcy happens, a company goes bankrupt, that's fine, but that company in it owes, let's say, thousands and 10,000 crores to other parties involved, who they were trading with. So it's never usually one company going down. It's a set of companies who go down together, because they were so interdependent on each other. And all the financiers on top of them, they are the actual people who lose a lot of money, because because money was the only thing they were putting at stake, and if something goes bankrupt, they lose a lot of money. Those are the people who are like willing to put in the money, put in the effort for platforms like this, who can increase a lot of transparency, just because they are based on top of blockchain. Of course, everything that I've discussed till now could have been implemented directly from a database, but this last point, where the trade financiers wanting to have this transparency just because they don't make a bigger loss next time, this is the primary reason of building everything on blockchain. And if you spend a lot of time over thinking about this, you'll try to find you'll try to understand why you'll come to understand why every time there is a scam, or every time there is a governance issue, it could have easily been resolved via blockchain voting. If you One of our partner companies happen to work on real estate tokenization, although it's a very difficult thing to do in India. But what and the aim was to provide fractional ownership, because if you look at real estate, it's out of reach for most of us. We can't really just go and buy a house without actually taking a huge loan. But if you were to buy, if you were given to the opportunity to buy one hundredth of a house in Mumbai, you would probably make that investment, just because you want to get into real estate. But the price of entry is so high that it becomes unreachable. But if because a house is sold as a single unit, but if you were to provide fractional ownership there, which people are working on, except only issue being liquidity. If there is no liquidity, you cannot really accomplish this, because at the end of the day, somebody really has to buy or sell that house, and if you can't do that in house, it becomes very difficult. But at the end of the day, those are the products which will really revolutionize the market, because it will change the way people invest. It will change the way people look at things. This is why we are very bullish on the technology itself, because no other way I see the real estate market disrupting, apart from fractional ownership, of course. So it's a good thing to implement. uh, Another thing which I came across doing, like I earlier discussed, was the power to power peer to peer power trading. So I'll have to give you a background for this. And so NTPC, on that, what on the Green India initiative, or switching over to renewable resources, wanted to have a 50 megawatt plant in a remote location in Madhya Pradesh. Now it's not just installing solar power panels and uh, just adding them to the grid. What they do is, they don't randomly install it anywhere. They go to a small village or a manufacturing area, let's just say, where there are a lot of industries. They install them on their rooftops, houses as well, houses, industries everywhere, and have a smart meter installed there also. Now the aim is to reduce the load on the grid. Okay, now since they're adding, let's say, a 50 megawatt plant, the aim is to reduce that 50 megawatt. And there is a huge power loss in transmitting power, so the lesser the distance between the source and the end user, the more efficient it becomes. Now what they plan to do was install those power the panels on top of the industries and houses there, install a smart meter with it as well. Now what that smart meter does is, if power is being generated on your rooftop, it redirects it to your own house, and if you have surplus, it gives it back to the grid. Now it might seem very simple. Okay, you use whatever you have, and whatever you don't have, you really pull it out from the grid. So very, very simple thing. Now what really happens is, uh, at the end of the day, there is billing need to be done as well. And billing is a very, very difficult scenario. Reason being, the discoms are um, the people who print the bill out, the government organizations that print your bill, the electricity bill out. So they buy at a X rate from, let's say, NTPC. And now the the rooftop guy, or whoever's house the panels are installed in, they become sellers as well. Now you can't really put a fixed price on it. Reason being, probably in the night, people might not need in such areas a lot of electricity, but in the morning, where their machines are running, where the power usage is high, the consumption will obviously change the price as well. So you can't put a fixed price on, I take at 8 rupees from NTPC, so I'll take at 8 rupees with them. It doesn't work that way. It can work, but then it won't be a fair model to work with at all. So what we ended up suggesting them was have a proper maker taker model. Of course, we need to define a time interval in which you will count that. You need to convert them into time blocks, otherwise it becomes very difficult. The problem statement itself becomes very difficult. So we chose a time period of, I think, 6 minutes, or something close to that. In some minutes, each of those minutes, and reason being, not a slow blockchain. The blockchain can take makes every block in 6 seconds. So in essence, we could have calculated every 6 seconds, but the meters themselves, when they connect to this, and they don't have that kind of variation also. So that is what we came an agreement on, to have it between 5 and 10 minutes. Then there is a maker taker model built on top of it, where at each of those blocks, people pay, people either, because nobody is really actually letting the electricity go. It's going, and you're retrospectively calculating what is gone and what has been come, what you have actually produced and what you have actually drawn. And what you've drawn can be a negative, which means you've supplied. But uh, this kind of billing now has to be done at each of the, now this data has to be picked up from each of these smart meters. These smart meters, think of them as IoT devices, because that's what they essentially are. And all of them get linked, and all this billing really happens at Discom. So NTPC wanted to build something right at the level where each of the, where the supplier and producer are the same person, can keep on determining a bill at the end of the 30-day cycle, where they just need to find out how much has to be paid or given back. So it's a very, very interesting use case, because you will find this kind of use case being implemented in all of energy trading. This was of course a solar power case, but you will see many companies building products out of it, because it is a very unique problem to solve, where the producer consumer, that line is blurred, and at each instance you need to do this calculation. So and such calculations, of course, if you don't build it on blockchain, it becomes very untrustworthy as well. Although NTPC again, PSU and Discoms always are state government associations, they themselves don't have mistrust between themselves. So it's not like if NTPC says something, Discoms are going to agree, because it's a center state scenario again. So they always need something to be built on blockchain, just because nobody can uh, at a later point disagree with things. What they later came up with was building uh, electric vehicles, and they have a implementation in one of the northeastern states to build electric vehicles for public transportation. And all of this supply chain, they wanted to be put on the blockchain. Another very interesting government project that I got a chance to work with was with the Indian Army. Uh, I got invited to have to consult on how we can build a blockchain solution for their supply chain of frozen meat and diesel uh, for the southern region. Because if you look at the initiative from the government, uh, they have listed down 6 technologies, and blockchain is one of them, to better equip the Indian Army. And at the end of the day, they the US military has already done it. They have every single ammunition uh, listed in a blockchain, where you can actually determine where it was produced and where all it traveled, every single ammunition. And that is a huge thing to accomplish. uh, and that is what I think India has been trying to aim. Probably 5 or 6 years down the line, they would want to aim that as well. But now they're just trying to do a POC, and that is where I got involved, where they acquire diesel from either HPCL or BPCL. And from that point on, it's a huge process till the point it gets filled in an actual army truck. There are hundreds of approvals from various stakeholders, and hundreds of verification levels at each point, where you know uh, more often than not, the weight of things change. And of course, in things like diesel, where there is a lot of evaporation, you need to have that tolerance limit also. Many different failure points. And blockchain independently, as I like to say, it doesn't really solve anything independently, right? It always has to be mapped to either a very good application, either based on IoT, because or people have started doing machine learning on top of, and analytics on top of blockchain, because in itself it's just solving, it's like a trust engine, as I like to call it. You can, even if all this talk about NTPC building this and that. At the end of the day, you will first have to build a normal application. Of course, you have to keep the blockchain paradigm in mind, but you have to build the normal application first. You have to build the smart meters are the IoT devices here. So blockchain just adds to the whole thing as a trust engine, and that is how it should be looked upon as well. Because any other when you talk to a lot of clients, they just think blockchain is going to come and solve problems, but that doesn't really happen. Trade finance was Gartner identified trade finance to be one of the most you know obvious use cases of blockchain where it has to be developed. But even till this day, only very few organizations, large organizations, are working on it. Of course, a lot of startups like us are working, but there has not been much progress yet. Reason being, the solutions themselves are not complete. By complete, I mean, if you again, I keep referring to the Niti Aayog paper for some reason. Uh, you will find out the all the current implementations of blockchain are not blockchain complete solutions, because they just focus on one very niche thing, they haven't built anything around. So until the whole ecosystem comes up and people get to work around all the different factors, including legal issues that arise, it will never grow exponentially. And if you look at predictions, I think 2023 is the point where blockchain complete solutions would be emerging a lot in the market and will become mainstream by 2025 or 26. So I think it's a very very good time to focus on such solutions, because one thing, it makes you get even more close to the industry. Reason being, when you develop just an application, you are not really bothered on how things happen in the real world. Of course, a product manager would care, a BA would care, but the person who's actually developing it, who's so far away from the real world, he doesn't really care. And that shows up in the product as well. But whenever you have a blockchain based product, you have to replicate the flow from a token perspective and map it to the real world. So it's a different paradigm, and that is how it will become successful over time, when people just completely start mapping those processes effectively on a blockchain. If you look at this chart where industry trends and progress, uh, I think, and it's based on impact versus feasibility. Now, of course, if the impact is high, public sector, of course, is like the most obvious answer, because at the end of the day, you know, uh, government is an intermediary between you and the constitution, in effect. I mean, of course, this is taking it too far, but that is in effect the relationship between the citizen and the constitution, where uh, the, the civil servants, etc., the government, etc., is just an intermediary. So it's very very natural to have, as the most highest, as the highest impact sector, that is the public sector, to be in the blockchain. But if you look at the feasibility, it doesn't really score very high. Reason being, of course, corruption being one of the biggest reasons. But that apart, also, the operational challenge that uh, it includes. Because if you look at very very simple things like, uh, it's not very simple though, but it looks simple, things like LPG subsidy, or implementation of Manrega and things like that. Although it sounds very simple, if somebody is getting this, pay him that, it sounds like more of an if else. But at the end of the day, if the number of users are too high, the implementation has between messed up between governments here and there, there is no proof. Now of course we have Aadhaar now, but if we didn't have Aadhaar, we can actually not get close to any of this things we are talking about. Reason being, if you don't have an identity to map to, which is recognized everywhere, at least in one jurisdiction, it becomes very difficult to operationalize this, because then again you would be generating your own ID, which doesn't make sense. So public sector, of course, the operational challenges are very very high, uh, and of course people don't want to do it because they want to have some things hidden for national interests, etc. Financial services and technology, media, and telecom. These have been technology, media, and telecom. Again, it's similar, but impact wise, it's maybe fine, but it's not very feasible. Financial services, and this is what we've been targeting, is the most uh, easiest to implement, I would say. Reason being, financial services are not. Of course, you have to take into account uh, the regulations of that jurisdiction, but that apart, many of the companies, like the financiers I was talking about, the huge trade funds that are working, they are open to build these out for you, help you guys build it. And this is the reason, the feasibility is high, because people are more receptive, because they think of this solution as a money saving solution. And if you look at and why do I keep bringing this point in between, because if you look at AI, if you look at ML, the ABCs, so AI and ML clearly try to showcase the monetary aspect of it. Let's say, you are a procurement company, and somebody shows you a module, based on ML, saying, if I can predict your this thing properly, your wastage will reduce and you will save X amount of dollars. But when you do a similar thing for blockchain, apart from you know uh, financial services or anything which is prone to scams or bankruptcies, or people running away with money, everything else, if you can't really prove a dollar, put a dollar value to justify the implementation. Reason being, let's just take manufacturing for example. Okay, it's a very good thing, you want to track uh, probably if something gets produced in X factory, gets joined to some other thing, and then there is a finished product somewhere else, you might want to track it, but the manufacturer actually doesn't have a lot of value for tracking that. He might just be interested to uh, know where his product is going to land up, and that's all he cares about. So in many of the sectors that you see on the left hand side of that graph, most of them, people, you'll not be able to put a dollar value easily. You can claim efficiencies, etc., but all those efficiencies and everything can be achieved even without blockchain. You can probably just have a very good ERP implementation, but can never make money out of it. But financial services, on the other hand, they've lost a lot of money because of lack of transparency. They know there are processes regarding involving banks which take up a lot of time, and the only thing they're solving is trust, and that is why the feasibility is very very high. And I foresee this market being oversaturated in India in the next 3-4 years, I believe. Next 3-4 years, every new startup would probably be having some kind of blockchain implementation, and lending or financing, bill discounting, invoice factoring, etc. Because this technology really really helps in such matters. I see. I think Udan has started hiring from VIT, which is again probably going to be one of the big supply chain companies of India. And at the end of the all of, and streamline everything in supply chain, financial services actually take over right after that. So we are at a very point where it's just going to explode this market. Because if you look at interest rates in India for things like let's just take for an example procurement for let's say a Taj, let's say Taj Bangalore, does procurement for 5 to uh, mm, maybe 7 crores yearly. So what do they really do? They say they want, let's say, linen or whatever is the hotel's requirement. They they always get a credit period of 90 days, 120 days, etc., because since they are Taj, everybody is willing to give them credit. But that is a very loss making thing for the vendor, because that is basically dead money, because he is not making money on top of it. But if somebody were to give cash discounts in India, they go as high as 4-5%. The unorganized lending in India is goes as high as to 8%. And people getting 1.5-2% consider themselves very lucky, and that translates to 18 to 24%. If you look at the world market, of course there is the dollar INR risk involved, but even then, eh, 7 to 8 to 10% is like the absolute high that I have seen on my platform, at least. That still leaves room for 8 to 10% to change. And if you look at the whole of India or the whole of the industry as an example, 10% is just too huge to miss. And there'll be a lot of people capitalizing on all these things, because the more broken the market, of course, India has its own set of problems, where recovering money is a very difficult thing to do, because the regulations are there, but the implementations to get that done are not. So that is the only reason it's broken. But probably in this decade coming forward, and although COVID hated by a lot of people, but that has proved the need to move away, the need to digitize everything. And at the end of the day, if it lands into blockchain, I think it will be very good for all of trade finance in general, because trade finance just in the commodity space is close to 17 trillion, 20 trillion dollars. And there is still a gap where people, 1.5 trillion dollars, where people want financing and it's not there. And that is just in the commodity space. Of course, commodities are a very good indication, because they act as a raw material for all the industries. But it's a very, very good thing to do. I see someone's been trying to raise his hand. If you could just go ahead and speak, I think. Can't see him now though. All right. Yeah. If you have something to say, I think we'll just put the last 15 minutes for discussing things. Absolutely no issues. Okay. If you were to look at very Indian centric implementations, and these have been funded partly by the government themselves. So uh, very glad to know that the government is also focusing a lot on this technology. The track and trace uh, in the pharmaceutical supply chain, it's very, very important when it comes to things like drugs. Okay, because you might not really care where your car was manufactured at, or where your phones are manufactured at, unless there is a problem. But even if there is a problem, you have somebody to repair it for you. But when it comes to pharmaceutical, it becomes a liability issue, because as to if somebody has done it, if there is something wrong with your drug, if there is something, because it's not just one medicine that goes wrong, it's a whole batch. So it's very, very important to be able to if somebody finds out retrospectively that something has gone wrong, it is highly important that where that shipment is, or where that batch of drugs is currently, so that you can stop it from supply. So that has been implemented already in India. Claim verification and approval for fertilizer subsidy. Not sure if you guys have much views on how the fertilizer subsidy works, but then uh, it's a tedious process for the farmer, if somebody is just starting out new, because eh, just like any other system where there are a lot of intermediaries. Even in the fertilizer subsidy, there are a lot of intermediaries. People end up buying a lot of from them and then selling out in the open market. And this has been one of the huge problems for farmers in India, where they're supposed to get it, but then the stock gets over because somebody else has already sold it, uh, and things like that. So if things are put onto the blockchain, it was natural for blockchain to disrupt this industry. Although they've not made it live, I believe, but then they're still working. Verification of university certificates. Now, this is something which I was discussing, of course, earlier as well. And the whole, if you look at, all of this transfer of land records, I think Maharashtra government has already done an implementation. The Karnataka government is also doing an implementation. University certificates, everything that you see here, the the original question comes to who is going to build the network, right? Because if some company is doing it alone, they will just build a private network. Ideally, such things who are very which are very very generic, or which are very very democratic, they could have been built by the government. And that is what this implementations are going towards. If you look at again Niti Aayog, they've identified these four as the primary things, and they've extensively been pushing on it. So transfer of land records, although it's a huge issue. If anyone, have you been involved, with your parents or relatives trying to buy a piece of land? It is just insane, the history it goes to. And if there is a flaw in any one of the transactions in the whole history, the whole deal might be compromised. uh, it goes back to 1960s, 70s, or whatever, but then everything is currently being verified by a lawyer. He ensures that whoever has signed on the other part has actually given his consent, etc. So all these implementations, they are set to revolutionize things, because if transfer of land records comes into picture, the fractional ownership that I'm talking about, that I was initially talking about, that becomes very simple to implement, right? Because if the government itself has a mechanism to show you all the land records, it's very simple. You just need a lot of liquidity, of course. If you can get liquidity from outside investment, fractional ownership becomes very very simple. So, and these are the implementations going on in India, at least. If you talk about the world, I think Maersk, you would have seen, they've gotten all of their suppliers and vendors in their consortium and build that out. Facebook with their Libra initiative, they've got a lot of industry big shots just to build their blockchain and maintain the network. If you go from a startups perspective, Comgo, WeTrade, Vact, all these people trying to revolutionize the trade and trade finance market. In India, I'm not remembering the name right now, but in India, the bill of lading digitization is what I was talking about. That is being pushed from India as well, one of the leading companies in the world. So a lot of implementations are going on. Of course, they don't get, none of them has become a unicorn or anything of that sort. But blockchain is certainly, having a lot more traction than it was having back in 17, where most of it was focused on cryptocurrencies. A recent Gartner study says 92% of those projects will never even have a product. That means they were all in effect scams, or people could not build the product out with the amount of money they raised. But they raised billions and billions in funding, and only 8% of them are actually ever going to make a product. So that was kind of the bad image back in 2017. And moving forward to 2020 and certainly 21, we will see a lot more implementations. We'll see a lot more people trying to do it, because if governments have started and completed projects, then probably uh, it's very shocking that they've built it at this fast pace. Now, if you go over to Infosys or TCS, TCS, I'm not that sure, but Wipro and Infosys, yes, they have their own proper blockchain divisions. IBM has done a lot of work in blockchain. You'll see custom made solutions for all the industries that were there in this space. You'll see custom made solutions built there, which allow people to configure and build it for them. The Indian Army solution that I was talking about, they probably decided to go with Infosys to work because their supply chain blockchain module already exists. So this is what people have been doing, and insane progress over the last 2 years, I would say. uh, Now, finally, as the last part, let's discuss some limitations of blockchain. Of course, there are high TPS issues, I mean low TPS issues, and things like that. But problem is, let's just assume the trade on my platform, right? If I just exchange that trade, and uh, let's say tomorrow there is a legal case on one of the counterparties, and they want to show proof. Well, there is absolutely no clarity that the blockchain proof will actually be able to hold its water in a court of law, because although it makes complete logical sense and everything, but since there is no framework around it, people might just not give it legal uh, you know uh, acknowledgement, because that's how things are. Even at the end of the day, if there is no document to sign, or which says, probably even in India you will see there are stamp papers which people end up signing and things like that. So unless there is something of that thing attached to your solution, it does not have legal standing, and that is a very huge uh, limitation. Reason being, although everything logically sound, if it can't hold up in a court of law, the customers themselves will never uh, completely acquire it. Data privacy issues. Now we keep talking about transparency, but at the end of the day, like I said, until the zero knowledge proof solutions have really picked up, and they become mainstream, and first of all, they need a lot more research. Currently there's not enough space where they can be researched, but uh, sorry, they're not in a place where they can be developed. But data privacy is in itself, if you think of a trader, what is he exactly doing? He's just taking something for cheaper and sending to somebody, selling to somebody else, just adding probably 5-10% on top. Now, if the other counterparty can see all those trades on the blockchain, and if they can identify where their supplier is buying from, the counterparty's business is gone in effect. And that is the reason we mask most important identifiers on our blockchain, so that it becomes very difficult for somebody to understand who that person is trading with. And that is a huge data privacy issue. Even in case of Bitcoin, although it's built for anonymity, but at the end of the day, when you convert that money to a actual currency, that place always asks you for KYC. Why is that? Because everything inside of Bitcoin can be traced on who took how much from which account. But who is that actual account, who is the actual person who owns the account, that can only be mapped to such places where converting the money. And that is why you would have seen in 2017 huge push from international exchanges like Poloniex, BitMEX, who never ever asked for any ID proof, were all requesting our passports. So data privacy is a huge issue, in blockchain, until many of the other solutions are, built to supplement this. Regulatory issue, obviously, with things. I remember back in 2018, I hadn't really joined the organization, but I was working very closely with them. And I think 2018 January is when Bitcoin fell, and on our website we had coin mentioned, although we have no relation with cryptocurrency. But DBS Bank was our partner bank, did not really like it, and was scared that the Monetary Authority of Singapore might, uh, uh, look DBS in the wrong way if they are associated with projects who are doing something in crypto, they stopped having a working relationship with us. Reason being, the lack of regulatory. It's not that there are regulations banning or allowing things, just the lack of regulation creates so much uncertainty, which is not really good for the industry. Because now let's say, I'll give you an even more recent example. Singapore passed a Payment Services Act last year, and that came into effect 28th of January this year. Now, the example which I gave of having a Paytm like wallet, now every such activity requires new licenses. This is something which is not available anywhere. Uh, of course, it's available in uh, some of the European countries, but Singapore is probably one of the most advanced countries who always leads into such things and embraces technology, and that is one of the primary reasons we are based off there as well. Now, just getting that license, they've actually come out with 7 licenses, and 2 of them actually deal with cryptocurrencies. Now they've allowed people to buy it, they've put regulations around it. So now such regulatory framework is completely missing from even larger jurisdictions like the United States. They have bans set in place but have no way to show how people to do it. So these issues, they limit the adoption of the technology itself. It's not probably the limitation of blockchain, it's the limitation of implementing it. IP issues, if most of the blockchain projects that you will see are all open source, you will always find their GitHub accounts, and you can always download it. What you build on top of it is what becomes yours. Now, in places where there are very specific blockchains which people have built. Uh, if I am not wrong, Harmony was one of them. And if you build something on top of them, then you really need to have a, a licensing relationship between them. It's because if the blockchain itself was not open source, if you build something on top of it, the IP issues arise all the time. Even within the team, since most of the projects are community driven projects are fine, because then they don't really worry too much about who's copying what. But the custom blockchains, very difficult to separate the blockchain from the application itself. So in our case, when all this uh, things were happening around the regulation, that is when we split the company into 2 pieces, where one just takes care of the application and the other just takes care of the blockchain. Now, IP issues will always arise if such things are done, because when you build something from a monolithic standpoint, right, it's not microservices architecture where everything is talking to each other. It's if you don't build it in that fashion, there are huge IP issues. So that is something you realize when you've actually built a lot of stuff around it. But uh, it doesn't like a huge problem in the beginning, but once you decide the structure on how you're actually going to make it, it really makes a difference. Crypto issues are, of course, like we've all seen. If uh, things like income tax, if you gain some money, nobody was sure if you how you're supposed to declare it. People are scared as well, not knowing if it's legal or not, although Supreme Court says everything is there is absolutely no rights for anybody to say it's not right now. But you never know when regulations keep changing. You can see drafts from the government where they've planned a stepwise banning of such things. So, and crypto is something which can uh, exist, you know independently of blockchain as well. If you look at how hyperledger and things work, they don't really need a crypto to operate. But any public blockchain, you would need to have some kind of incentive mechanism to incentivize the node. Now, if you can't do that, uh, you can't run a public network. But if you are running a public network, you need to have some kind of crypto. So if you look at projects like Terra, what they've done is they pay out rewards in terms of uh, a stable currency, like they are based out of Korea, so of course they deal in the Korean currency. But that is what people are trying to do. People don't really have a problem with crypto. People have a problem with speculation around crypto. The volatility that the currency has becomes a challenge to maintain their own business. So I think over a period of time this will get easily resolved. But certainly, this is part of the problem around regulations themselves and rigid smart contract issues. Although, till some extent we have gone ahead and solved it, but most of the projects that you see, blockchain projects that you will see are mostly built on top of Ethereum. Reason being, Bitcoin wasn't really that configurable when it came out initially. Of course, when they had uh, I think after 2017 they launched something which you can develop a lot of applications, but Ethereum was the one which provided the framework for people to build those smart contracts. But each time you make a change, it technically spawns a new chain. So although the history is there, and the history itself is verifiable because of the Merkle hash, but uh, it was very difficult till this point, and that is what we've been working on as well to just very simple example would be, let's say, I decide to finance somebody for LIBOR plus 2, and I don't really know when I'm going to change it. And now that LIBOR itself keeps changing daily, now at the end of the day, I want to give an extra discount. But if my order is created in a way which picks up the original, original negotiated amount, how do I change it at the end of the day? If there is a last moment change. So things like this, until you create, of course, you can always create a different contract. But the last thing, the last step changes and discounts and things like that, if they're not planned earlier, it's very difficult to execute. And it's not like a place where users can call up customer service and tell them this is wrong or that is wrong. If, very very important example is, whenever you create an account, you get a 24 word seed. Now that seed is the one which can recover your account. And as regulation has it, the companies who are providing it cannot store the seed. It's think of it like the whole credit card detail, but which the companies are not allowed to store. So because you can generate a key with that. Now if a customer loses a seed, in effect he has lost everything. But when you build something out for the users, you cannot have such rigid restrictions around it. So it becomes a very huge operational challenge to come out of this rigidity of the whole uh, ecosystem. It's not just a problem of one single blockchain which the other one will solve. It's just a problem which exists, and that is how it brings trust, because you can't really recover people's accounts randomly. So these are some limitations which prevent adoption, because all the users might everybody is used to forgot password and send an email out and get everything done. But uh, such things cannot really be made on blockchain based applications. So I think covered most of the things that I wanted to cover. Of course, the slides were very tech centric. Could not find the time for many diagrams, but would have loved to showcase a lot more at some point. You can find the videos. If you want to take a code deep dive, from the co-founder of Persistence, you will find we run a Cosmos uh, marketing initiative in India to develop the community around it for developers as well. We host hackathons for all the upcoming developers also in the blockchain space. So you will find many of those workshops online where people from our team are explaining and trying to uh, just spawn a blockchain with a simple wallet and bank transfers instantly. And you'll see many projects around it which have made it very simple to get into the space. So uh, I think I've covered what all I just wanted to cover today. uh, Okay, guys, if you have anything to ask, please shoot. Would love to answer your questions also.
Thank you, Abhishek.